Everybody to our workshop. I would like to say special thanks to people in the room, Andy and Kaiwen, who are helping us with the workshop. Because of the travel problems with the weather, we were actually not able to arrive. People will maybe get flights cancelled or delayed. So we are very thankful for your help. And we will be starting workshop by doing a little bit of welcome, like
Yes, to you. No, wait.
saying,
Why?
like saying what is those workshops about, or where we come from and where we are going. So this is the 11 number in our workshop. We're doing it for several years. Serverless computing is evolving, and we hope we can catch up with what are changing. And the idea is to keep here a connection between industry and academia. So the workshops are open. We really look forward to your questions, interactions, and we will be also putting the recording of the workshop, keynotes, and all the sessions on YouTube. And please join our Discord channel for this workshop and keep up with what we are doing. In particular, we recommend please join our mailing list. It's very low volume, just key announcements about workshops and so on. We also have the Blue Sky account, and keep also checking our serverless workshops website, and of course YouTube channel. So this is, we also organize the purely online workshops, like we call it WoSC11. So you can see, the one that was in few months ago. And here's that workshop would not be happening if for our program committee to review all the papers that we received. So we are very thankful to them as well. And the list of program committee is also on our website. And then finally, please, as I said, join our Discord and WoSC11 channel if you are in the workshop to ask your questions or for any interactions with the speakers. And we will be now moving to the first part of the workshop, which is the keynote. And Julian will be talking about future of serverless and beyond. So I am going now to stop sharing, and Julian, please feel free to start. Make sure you are not on mute.
That's always a good start. Check if you're not on mute. Hello, everybody. Alex, can you view my slides just to check that I'm?
You need to share it again.
I need to share it again. Okay, thank you. I'll get there.
I can see your slides. You can go.
Okay, perfect. Well, hello, everybody. Welcome. I gather there are, weather delays and everything in the US. So wherever you're joining from, whether you are in Nashville or not, it's a pleasure to be here with you as well. Anytime, it's amazing to actually see when there's an 11th international workshop on serverless computing. That's fantastic to see the sort of long iteration and long time that serverless has actually been a thing. My name's Julian. I work for AWS, so that's Amazon Web Services. So obviously what I'm talking about today is sort of AWS specific, but I'm a very firm believer that serverless is way bigger than AWS, even though I work there. And as I said, 11 years of serverless, many other cloud providers, many other local implementations, many ways of doing serverless. I am originally from Cape Town in South Africa. I now live in London. I was actually in Nashville for 2 years ago. We put on a conference called Event Driven Architectures Day in Nashville. And I promise you I'm not lying, but I think Nashville may be one of my favorite cities in all of the US. It was a lovely day. And obviously, with music and barbecue, what can you go wrong? I'm a keen runner as well. So I ran around Vanderbilt University and it was amazing. So yeah, it's so nice to sort of virtually be back and talking to you about serverless today. So today is also a flexible kind of talk. I've got some things to talk about as well, but we are on Discord and we are on Zoom. So if you have any questions or comments, please pop them in. I'm happy to answer questions, happy to have more of a discussion. I'd far rather this be more than just me talking to all of you. But if you have questions, comments, or feedback for me, that would be super appreciated. So yeah, let's go. So I mean, I want to start by saying, we mentioned the 11 years. I mean, serverless has been revolutionary and in a way, sort of even a lot longer than that. And just from an AWS side, we had some services that, whether you've used AWS or not, S3 is an object store and SQS is a queuing service. And these were one of the two services that AWS came out of because there was a need from Amazon and our customers to just have object storage and to have a queue. And we knew that we needed to delight developer experience. We didn't want infrastructure to manage. We didn't want people to do a whole bunch of what we call undifferentiated heavy lifting, which is the stuff you don't have to worry about. And so these were some of the sort of original AWS services. And also at the same time, there were, other companies, even Microsoft was starting to build a PaaS platform, and other kind of things were happening in the space where people knew that infrastructure was something that was commodity, and we wanted to move a little bit up the stack and just make life a little bit simpler. In the AWS world, we came up with more services. SNS was a pub subtopic. DynamoDB is our own NoSQL database. Again, serverless services, many years ago. And these were sort of, before and after when we came out with Amazon EC2. So this was actually running virtual machines in the cloud. This is one of the sort of huge, big at scale ways where you could just use an API call and spin up a virtual machine. But you can see SQS and S3, which were serverless services, actually came before you could run EC2 instances in the cloud. So in a way, we've actually been doing serverless in the cloud longer than even running virtual machines, which is an interesting sort of bit of a history lesson to think about how long we've actually been doing this for. But obviously, the big moment sort of happened in 2014 where a service called AWS Lambda came out. And this was all about just uploading your code to the cloud. And then we will figure out how to run it, what we need to do, and how it would all actually work. And that was the sort of, some people say, sort of some of the birth of when the actual term serverless was coined. But there are many more things with serverless as well. For example, Fargate, which is a way that you could run serverless containers in the cloud, and lots of other kind of serverless services from Microsoft and Google and Cloudflare as well, running lots of different serverless things. And I would sort of argue to say that, in fact, in this day and age, 2025, this is often the default way that people are wanting to build serverless services in the cloud, is to use a serverless way because that's the best way for people. But across AWS, serverless is absolutely huge. We have, compute offerings and storage and workflows and analytics and Gen AI and all these kind of things. And so this is a very important part to talk about, that serverless isn't just about running your code in the cloud, or isn't just about discrete little things that you can do at small scale, but it's sort of fundamental to the way that AWS as a cloud provider operates. And many of you operate when you're exploring and doing and building things in the cloud. Because what actually is serverless, if you had to sort of flip it around? The whole point of serverless is actually reducing the operational overhead. And this isn't just about abstracting away infrastructure, but in many years at AWS is about wrapping APIs, is about wrapping up the APIs that we provide to be able to make it much simpler. Developer experience is super important because basically we want you, and you want to do more with less and to be able to move faster. And to have seamless integrations. Your application isn't just some compute and some code. It's databases and streams and caches. And, serverless really wants you to be able to connect to any other service seamlessly as you build your applications. And of course, performance is super important. Scaling while balancing costs is super hard, but serverless has many features, limits and pricings, and this can sort of scale with you and your application, regardless of whether a university student, small teams, or an enterprise with hundreds of thousands of developers. And sort of with serverless, you can replace all the layers on the left with simple API calls, and then this is where our integrations come in. Without you having to build up all this infrastructure to just test and run kind of things. And the choices of infrastructure is up to you. It is your decision, but you still have to manage it. And when you're going serverless from an AWS perspective and many other providers, AWS does it for you. And there is a bit of a trivia question. We could do this virtually with hands, but the biggest secret of serverless is, well, actually, there are a heck of a lot of servers underneath, like literally hundreds of thousands of servers. And so I'm sorry if you've got to this stage in your serverless journey, and this is terrible for you to understand. But of course, there's servers underneath serverless. I sometimes liken it to wireless, where in America, you have a cell phone networks. In lots of other parts of the world, it's a sort of Wi-Fi connection. And although your interaction with the Wi-Fi connection is wireless, there are no wires. Behind the scenes, there are a huge number of wires connecting all the switches up together. You just don't need to think about them and care about them, because we as serverless providers manage all the underlying infrastructure for you, so you can focus on what you need to do for your business. And the whole big thing is being able to faster time to market. So when you have a concept and idea, you want to get that into production, you want to test it out, whether this is at small scale with a small little project or literally running global massive workloads that make serious amounts of money or move the world in some kind of amazing way. And when you use a serverless approach, it's being able to use this flywheel to go fast around the flywheel to be able to do kind of things. And for you as university students, it really is a faster way that you can sort of learn, explore, experiment, play, and prove things out. When you're not having to deal with a whole bunch of stuff behind the scenes, this allows you to learn and experiment and explore with Gen AI, the big zeitgeist at the moment, and to be able to do a lot of this much quicker because you're using the serverless approach. And I mean, this is a bit of a NASCAR side, but it's also, if you're studying and doing serverless things at the moment, your future is super bright because serverless is absolutely everywhere, used in every industry, in every vertical, and every geography, in every company. I mean, if you just look at the icons on the screen over here, if you're studying serverless architectures and you want to work in the future, you certainly are on a great way, on a great train because basically everybody is using it in various shapes or forms. I also like to say that I think serverless is also possibly a terrible term because I don't like to name things named for what they aren't rather than what they are. So serverless is no service. Okay, that doesn't really tell you much of what it is. So I alluded to the infrastructure, lack of infrastructure to manage and the availability and all this kind of things and the lack of service, but it doesn't tell you what it is. It's sort of, and it's not just serverless I have this bugbear with, it's also NoSQL. So you talk about NoSQL databases. It's like, okay, it's NoSQL, but what is it? So serverless, we are stuck with it as a term, and it has some amazing powers. But yeah, I wouldn't get too hung up with the actual term of serverless and being less servers. There's just a lot more that it actually encompasses. So I wanted to do just a little section today about serverless and Gen AI, and in sort of two sections, using AI to build serverless apps, and then building AI apps using a serverless approach, because I sort of get the impression from my playing, and I know looking at the agenda for today, that serverless and AI is obviously a very big topic that people are looking at. And I think you're in an amazing place as students doing research and understanding how best to do this. So let's just quickly, I want to show a demo application that I built when you're using an AI tools to be able to build some serverless applications. So I'm not sure if people are aware of MCP. MCP is the Model Context Protocol, and this is an abstraction for AI to be able to talk to tools, to be able to talk to resources. And some people call it the API for Gen AI, some people call it the USB plugin port for Gen AI. But it's basically a way that you can be able to use resources on the internet, but a local client, a Gen AI, local AI client can use information and do its clever things that AI can do for it as well. So the Model Context Protocol, the API for Gen AI. And there are MCP servers for absolutely everything. This isn't just an AWS thing. If you're using PostgreSQL, or using Stripe, or using GitHub, or using Firebase, or using JetBrains, or using anything, the world went absolutely mad in 2025, creating MCP servers to be able to provide another way that you can access information. And of course, you could have accessed this before via API calls, but you probably needed an SDK, or you probably need a website to be able to connect to it. Now, using MCP, it allows you to plug this information into your local IDE, or your local chatbots, or your Claude, or your Cursor, or your Copilots, or your or Gemini, or whatever, and get access to the world's information in a standardized way. So I just want to show this example because we also have an AWS serverless MCP server, and this gives you AI superpowers to help you build modern applications. We've got things like contextual guidance, being able to help create, build, deploy, and test applications, tools to build web apps. You can use infrastructure as code, adding observability, and then many more things coming. This is being iterated over really quickly. And so I'm not going to go through the entire demo, but I just want to show you sort of what's possible to be able to build some AI applications. So I have a local IDE and a local CLI tool set up over here. But it doesn't actually matter which that one is. I'm happening to use one called Amazon Q. We've recently renamed it Kiro. So we've got a Kiro CLI, and Kiro is a great open source IDE built for Gen AI. But whether you're using Claude Code or Cursor or Gemini, and I said anything, it doesn't really matter, because the power of MCP is you just connect these up and you've got all these applications to be able to talk to. So basically what I've done is I've set up my local application to be able to access this AWS Serverless MCP server, which has a whole bunch of tools which I can use. So I just give it a prompt. And in natural language, I say, I want to build the backend for a new to-do list application in a new workspace. I want to be able to add list and delete to-dos. Would AWS Lambda be a good choice for this? And you can see here, the demo is going off and I've got a whole bunch of tools and I've put my natural language prompt. And this is then going to run an MCP server, which is going to use the get Lambda guidance tool. And this is going to do some analysis of what I've asked it for and said, well, yes, Lambda would actually be an excellent choice for your to-do list application. And it's given a whole bunch of reasons for it. A lot of them are serverless-based reasons because you don't want to manage servers. It's cost-effective. It's got built-in monitoring. It's got some recommended architectures, some considerations to think about, and do all that. So this is super useful. I can get information on what I want to build before I've even started building. And of course, you can plug MCP servers into various other kind of tools and ask your GenAI questions about whether this architecture would be valid. What are the tools? What would be the use cases? What would be the contrary use cases for doing this? Why wouldn't I? And use the AI with the best practices built in and the information. So as I said, I'm not going to go through all the demo, but these are the kind of prompts I would have written. So later I want to deploy this application. Which infrastructure as code tool would be best for this? And this is going to grab some infrastructure as code information. And we've got a number of ones at AWS. There are also some third-party ones, which you could also ask information about. So in natural language, I'm just saying, can you go and please create and build my application? And this is going to go and do some thinking. So you can see it's actually doing it's running another tool called SAM-init, which is an initialization process. And this is going to locally build a serverless application. You can see all the files appearing on the left-hand side. And because it's a to-do list application, this is building some source files. We've got some function code. This happens to be in Node.js. It's using Lambda functions. So you've got one to add a to-do list, one to list a to-do, and one to then delete a to-do. You can see just looking there, I've got a package.json, so it's created all my dependencies. I've got some JSON structures for some event objects, which I can use for testing. So this is great. My AI application is basically, scaffolding this is a simple use case, but, can be a microservice I'm building or something else. This is actually building my application and realized, I've actually made a mistake. One of the little configuration options for creating a database had the incorrect bit of information. So be able to look at that, see that there was an error and be able to, iterate and then rebuild the application and do everything. GenAI is obviously also great for creating documentation. So off it's done, and it's created the scaffolding for my serverless application with some sample event objects, a infrastructure as code, which is always great. So you can build these kind of things. That's really good. So what I can do is I can say, can you deploy it, please? I can also do some additional prompts like, can you add some additional things into my database, some helpful to-dos about improving this application? I can do some further prompts. I want to do some observability things. Can you, check the logs and metrics of the to-do app for any issues? Can you add observability best practices? AWS Lambda Power Tools is an open source tool. But the whole point of this is I'm just writing natural language. And then lastly, I've built all the backend and say, can you write a snazzy, may as well be a snazzy front end that I can run locally, then that can connect to the to-do list application. So instead of having to hard code all of this, write this all out, I'm just using an AI application. But instead of just using an AI model that's just going to write code for me, this is actually using the MCP server to connect to AWS to be able to get information and best practices about how to set this all up. So let's look at the front end, for example. I just can change into the to-do. I do an npm install, which is going to install everything. You can see all my node modules are appearing. And then I can just run this app locally, normal npm start, and off I go. So if I open this up in a browser, I now have a front-end serverless application connecting to my backend in the cloud. I've got the 5 to-dos that were created as part of it. I can decide to do another to-do to say do more with serverless and MCP. I can add that to-do. I can see the front end has been updated with some nice notifications. I can delete that as well. And this has all been built. So this literally only took me a few hours to do. Part of it was my own uselessness with creating front ends and being able to make sure that this all works nicely because I wanted it to be for a demo. But the point is connecting to an MCP server, being able to connect to do a front end, be able to explore, be able to iterate is super useful with an MCP server. And just talking some releases recently, AWS has an MCP server, a sort of generic MCP server, and this has all information about the whole AWS API and also all the knowledge bases. And the knowledge base is actually amazing because a lot of it's public information, but a lot of it is all our support cases and everything, which is all wrapped up into AI. So you can basically get the benefits of our standard operating procedures that guide AI agents through a whole bunch of common tasks on AWS. So this is it's a remote MCP server. It's fully managed, but you basically get the best and brightest information all about deploying on AWS, just being able to connect it to your local MCP server client. So the other part I wanted to talk about is, serverless and AI is actually building AI applications. So this isn't using AI to build an application, but you want an AI application. And the cool thing to realize is Gen AI is just another workload. Everything you know and hopefully love about serverless still applies. Because what is serverless all about? It's less infrastructure to manage. You're building AI applications. It's often got variable compute demands. Pay-per use is very useful. There's a lot of async event-driven processing, perfect for serverless applications. AI can respond to events like creating orders or doing inquiries or inventory changes. Automatic scaling. You don't know how many people are going to use your AI application, and serverless has a whole bunch of automatic scaling built in, can handle traffic spikes without you having to do a whole bunch of capacity planning. So your existing serverless skills transfer directly. Observability, cost optimization, all these kind of things built in. But there's a little bit more, and I don't want to go and talk too much about all AWS services, but we have a particular AI service called Amazon Bedrock, and this is a serverless service. And this is basically a serverless inferring service, which allows you to use a whole bunch of different models, and they're AWS models and third-party models, and you pay per the API call, and there's automatic scaling on demand. You just run an SDK. You can even use the OpenAI SDK. You can use any SDK. We've got a Strands SDK for building agents. You can do anything. It's very open and available to be able to use a whole bunch of AI functionality on AWS. And, not making this AWS specific, other cloud providers have this kind of thing. And the point is, if you look around the Gen AI landscape, most of it is just good old serverless, because you also, when you're building AI applications, you want to be integrating with a lot of other kind of services. You need various compute options you maybe need. You maybe need to run some workflows, or you need to do some event routing, or you need to do some storage or database things. And this is all standard building applications. And so the sort of marriage of AI running AI as a managed service in the cloud is super useful, because you've got lots of models, open source ones, closed source ones, any kind of model, and then connecting it with other kind of integrations with all your different places. And so the other thing to understand about AI is there are two main parts of AI relevant: agents, which are the orchestrators, and then tools, which are the executors. And so agents sort of run in an orchestrated loop, and it's something you've told it to do. And I don't know if you've seen the sort of pictures, but basically that's what an agent is. It just goes round and round a loop. It's sort of a while then loop until something has been satisfied, or you exit from the loop to tell it what you're going to do. And what it does is it calls tools to do things, and then is going to figure out the next steps to satisfy your request. And agents are often long running. They need to maintain state, and they need to keep things going and have some stateful interactions. And so when you're thinking from a serverless approach, particularly with AWS, well, you often decide, are your agents going to be short running or long running? And then you're going to pick the sort of serverless compute option that's best. But what if we actually learned from more than a decade of serverless? Rather than you actually rather want to use a service that's actually made directly for the job. So as part of Bedrock, Agent Core is a functionality of Bedrock, and this is actually built for running agents and then abstracts a lot of the heavy lifting. So of course you could run an agent in a Fargate container, or in a Lambda function, or on premises, or on your Raspberry Pi, or anywhere. Once you start having to think about some of the bigger considerations of scale and performance and availability and security and all these kind of things, you want to be able to use a managed service for the job, and that's going to be much better. And so the true serverless way, and this isn't just about Gen AI and Bedrock, is I encourage you when you're building applications is find the functionality that you want to use and head as far up the stack as you can to be able to find out, to be able to use that. Now, that is true 100% to be able to explore and understand things, but you're also university students, and I think also heading down the stack to understand how all the things work is also super important. So that's why I love all the talks that are coming up as well, because that's diving deep into some of the various aspects of AI workloads and serverless workloads, all the way down to the hardware and all the way down to the chips, because any kind of knowledge that you know about all of the stack is going to be super useful as a research perspective. But certainly when you're running things in production, heading further up the stack is the sort of serverless way that if there's a managed way to do thing, or there's a SaaS service to do something, you really want to leverage that rather than having to build your own, unless it's for purely research things. So, just talking about Agent Core, I mean, this isn't a sales pitch for that at all, really. But ultimately, it comes with a whole bunch of functionality. There's secure runtimes and gateways and persistent knowledge and identity and all these kind of things. And the point is, you could build all of these yourself. But the cool thing about grabbing a managed service is this makes it super useful to just be able to get started. The Agent Core itself happens to be any kind of framework, whether you're using OpenAI strands or Llama Index, LangGraph, or anything, any kind of protocol. So the cool thing is you can marry the sort of open source, open way of doing Gen AI with a managed service that can just handle a lot of the undifferentiated stuff. So you don't have to manage an API or manage an identity service or manage any memory persistent knowledge. You can focus on your agents, you can focus on your code. So that's on the one side, and then the tools on the other side, and this is what agents call to actually do something. And the tools are what you likely already have. So something you have behind an API that needs to read or write from a database, does some action, maybe needs to connect to your private data. And these are actually the deterministic parts. You sort of know how they work and what the functions they perform. And so this is great for avoiding the hallucinations. And in fact, I think on the whole sort of AI side, you actually want to focus more on the tools kind of side, because they are deterministic. And I think you want your agents to be as lightweight as possible, but then connecting to these deterministic tools, because it's got a lot of superpowers. First of all, being able to connect to your actual data, input and output stuff. There's no hallucinations. But also, if you're exploring, the nice thing about MCP is even if you don't have robust APIs yet, you haven't quite figured out what they're going to be. If you have MCP in front of them, you've got more freedom to experiment. As APIs are forever, that's a sort of quote that a lot of people have, because you do have a contract with the APIs, but MCP is able to abstract a lot of them. So having MCP in front of your tools allows you to be much more flexible in the way you can provide the APIs for your tools, and to be able to have the deterministic output from the tools that your LLM can then use. And of course, Lambda is great for tools because it is fast startup, secures anything, connects to anything, your data, and all those kind of things. So, an example, if you're building a customer service AI agent and to integrate with some existing functionality, a customer inquiry is going to go onto an agent using MCP. So you've got a long-running agent that is running over there. And then you've got some sort of gateway. I'm using Agent Core in this example, but you've got some sort of managed gateway is going to then be able to connect to some API targets or connect to some Lambda function targets, which is then going to connect to your other data. So, you've got to talking to a third-party payment provider or checking inventory and all this kind of things. And so you're not having to run a whole bunch of code to run those gateways, handle the auth, handle the authentication, or run the agent infrastructure itself. You've just got your agent code, you've just got your APIs, you've just got your tools that you can connect to. And so this is the serverless approach in a nutshell, being able to move a bit up the stack and be able to use managed services as much as you can. That was just a sort of a quick look at the AI kind of thing. But a lot of people I talk to, and I'd love to hear your feedback, and please prompt me and play devil's advocate as well. I'd love that as well. Is a lot of people, even after 10, 11, 14 years of the serverless, says, but I won't do serverless because, and they have a lot of reasons for that as well. And some of them are, well, certainly serverless is great for my hobby projects. I'm just a student. I've built in a little mini application and something that's absolutely great, but surely this can't be used for anything in production, and surely this can't scale. So obviously at AWS and Amazon, we use this at ridiculous scale. So, I've been talking about Lambda as well. Lambda has more than 15 trillion requests each month. And Prime Day, which is our sort of one of our Amazon.com sales days, 1.7 trillion Lambda functions ran on that one day. And that sounds impressive as well. But Amazon is just another tenant of AWS Lambda. There are all other customers, maybe your Vanderbilt University, your sports teams, your Netflixes, your McDonald's, all these other companies that I showed in the slide before, are still running their workloads at the same time. And so this elasticity, the scale is super impressive for production tasks. Amazon ECS, which is for running containers, 3 billion tasks launched each week. This is at absolutely massive scale and gives you the performance. Step functions is a workflow orchestration, 16,000 API actions, billions of workloads. I mean, the point is there's just a huge amount of stuff that runs at scale. Performance is also a big consideration. Cold starts. I've spent many of my years at AWS talking about cold starts, and of course this is something to consider. But there's been so much work done at AWS and also within the wider industry to be able to make cold starts far less of a problem than it's going to be. A lot of it is just code and language optimizations, whether you're running, Node or Python, the way you import libraries, the amount of information you process, the way you can set things up, just a huge amount of language things that you can do. You can compile native languages, it can be natively using, Rust or Go or those kind of things, or using GraalVM for Java or using .NET AOT, a whole lot of ways to do native compilation. For various kind of application runtimes or language runtimes to make cold starts far less applicable. And all of these things, whether you're running on AWS or anywhere else, this is just good software optimization, and these are things that you can do. Things like GraalVM, for example, for Java, it's not an AWS thing, but the industry realized that cold starts for Java is a problem with running the JVM, and so really rallied around trying to create more opportunities to be able to do better things across anywhere that you can run Java. At AWS, there are a whole bunch of platform features we come out, things to be able to run your cold starts in advance, to be able to create snapshots and resume snapshots. A lot of academic interest in this as well. If you do some, Googling online and you look about Snapstart and things like that, a lot of innovation that we've built at the platform layer to be able to handle that performance for you, which is all about running production workloads at scale with high performance. Another thing people say to me about serverless is like, well, it's different. It's not the way I'm used to running things. I run things on my laptop. I push things up. Serverless is different. The thing is, you need to ask yourself, is it really different? If you're talking about serverless and code, it's a whole bunch of standard languages. It's Java and Ruby and Python and Go and Rust and even PowerShell and COBOL and all these kind of things which you can run. Forget code, if you're running a serverless database, it's Postgres, it's MySQL, it's all these standard kind of things that people are doing just in a serverless way. Observability, you can use OTel for serverless observability. It's writing log files, it is creating traces, it is doing logs metrics and all those kind of things. That's standard kind of things. It's container images. If you're using Docker on your local web machine and you're pushing it up to a repository and building a Lambda function or running a container on AWS and one of our many container kind of things, or other third-party or other cloud providers, a lot of the serverless stuff is just a container. It's the same kind of thing that you're doing on your laptop. One of the particular things about Lambda is, well, it's an event-based model, a bit of a technical nuance into that, but you can run some code that turns it into a web adapter. So, there's a lot of things where people say, well, serverless is actually different, but as the years go by, serverless becomes more and more the normal, and in fact becomes less and less different, and some of the other things become, more differentiated. And something we came out recently, we're talking about things being different. We've got some orchestration services, and you've got Apache Airflow, or you've got step functions, all these kind of things. And so we just came out at our conference recently with Lambda, a thing called durable functions, where you can just have asynchronous functions that can run up for a year, written in your code. It's just an SDK. Durable functions or durable executions is a very wide industry thing, which is super useful. And we've just now built this into one of our services. So you can run sequential code in your preferred programming languages. Durable functions can track progress. They can automatically retry on failures, suspend execution up for a year, a checkpoint and replay mechanism called durable executions, as I mentioned, to do these. And this is actually a fascinating sort of evolution of serverless. And other providers are providing similar functionality as well. And this is a really great way. And in fact, I would argue it would be very hard to actually provide durable, durable executions without doing a whole bunch of infrastructure provisioning behind the scenes. And so again, a serverless provider can just handle this all for you and give you amazing functionality. And the point about it being different is, well, this is now, instead of having to run workflows or create workflow definitions and other kind of things, you can just run this in normal function code. You can test it locally. You can run it locally. You can, deploy it into multiple places. And this is just an amazing one to make serverless less different. Another one, the considerations is all about cost. And that's an interesting thing because serverless pricing is one of the amazing superpowers of computing because it is all pay per value, pay per use. And so you've got extremely granular visualization and visibility of your serverless use. Lambda's 1 millisecond. So per millisecond, you know exactly what's going on. If you had to run something, and of course, if you had to rent some servers and you had to install something and you had to run things, you've actually got no idea of your individual function calls or your individual database calls, what they cost. But with serverless, you do. The other concern, which is entirely valid, is, well, of course, I'm going to have build shock. Things are going to run away. And sure, so, AWS, other providers also have capacity caps where you can't, have runaway capacity. You've got alerting on your budgets to do kind of things. Savings plans, which is you pay in advance for some committed things. And this can be for databases or compute or networking for a whole bunch of things. And that can save you money as well. We also came out recently with Lambda managed instances, where you can run any EC2 instance or many EC2 instances to run Lambda behind the scenes with multi-concurrency built in. Another way that you can save costs. And in fact, from AWS's perspective, we try to lower costs as much as possible to make things as simple for you as well, and then give you the controls that you can also do your cost controls, so your budget's not going to run away. And especially for experimenting and playing around, this is amazing. And then as you get to higher scale, we obviously want to be able to be there with you and not that you have to leave Lambda or leave the serverless service to be able to do things at scale. So just another example is, logging costs, just something that people think like, really, is this an important kind of thing? But, optimizing your logging costs can actually be an easy win. I mean, we came up with some tiered pricing this year. The more you log, the cheaper it gets, and without you having to do anything. And that's also one of the huge big things about serverless is the serverless ecosystem just continually evolves behind the scenes, and things get faster, things get cheaper, things get more available. Things just happen behind the scenes and you don't have to do anything. And that is absolutely great. You've got structured logging. You can set, picking your log retention levels, for your, if you're in your dev environments, maybe you only need to keep logs for a day or 10 days or that kind of thing. Production may be longer. You can pick that as well. You don't need to pay for logs you're never going to actually use. You can, you don't log what you don't need. This means you've got options in what you're going to log. You can just have key identifiers. You don't have to put massive amounts of things in logs. So yeah, just something as simple as your sort of logging infrastructure. There's a lot of functionality and a lot of considerations we've been able to give you that you're able to do kind of things. Because the cool thing about serverless is cost actually equals architecture. And when you're building with serverless architecture, you have extremely high visibility into your costs, and you are able to marry your costs of your architecture. And as it grows, you know how each part is going to scale and have very deep understanding of your costs. And if costs don't work for you, well, you can migrate to other kind of options as well, but you've got that visibility in, and you could adopt containers at scale, or you can do other kind of things or move things in other kind of places because you want that flexibility to move things around. Developer experience is one of the big things that people complain or say that serverless is much harder and it goes to difference, because there is this development loop of where you have this sort of inner loop where you're doing local development and local testing on your workstation, on your laptop, and then your cloud and your CI/CD pipelines where you're going to deliver things. And the thing is, serverless does actually make this much harder. Because you are connecting many more services, and that means there are many more things to look after. And so serverless is a mindset shift, because you are connecting a whole bunch of different things together. But we've been coming out, and the industry has been coming out with a huge amount of things to be able to prove developer experience. Visual Studio Code, which is the most common code editor, has had a explosion of different clones this year. From Kira, as mentioned, which is an Amazon one, but from Cursor or Windsurf and all these kind of things. And we are, and other people are building amazing integrations into this. I'm going to show one of them shortly, where you can set up your applications, you can initialize functions, initialize databases, do all these kind of things. I showed about connecting to the MCP service. This is amazing. You are sitting in your local IDE. You don't have to jump to a console, jump to anything else. You can just be able to connect to this as well. We've got amazing new functionality to be able to local debug, to be able to, if you've built a Lambda function, for example, in the AWS console, you can literally in one click just move it to your IDE, do local debugging. You can do remote debugging. I'll show you that quickly. That's a super thing that's come out. Step functions is our workflows. Lots of functionality that is being built into there to make that simpler. We've got serverless WebSockets with AppSync. EventBridge dropped its latency by 80% just behind the scenes. You don't have to pay anything extra for that. Just happened. And this created amazing new workflows and amazing new capabilities that you can use sort of async WebSocket APIs to update front ends or, print tickets out at a till and just drastically reducing that latency. So the thing is, behind the scenes, we've got developer experience, a lot of work going on in the industry and AWS to make that much simpler to be able to use. I love this remote debugging. So we're in my local IDE over here, and I've got a Lambda function. I'm literally going to click on remote debugging, and I'm going to click on remote debugging. It sets up a whole debug session. I mean, I can go into more detail behind the scenes with that's happening. But basically, the red dot you can see, I have a breakpoint in my code. And ultimately, I didn't have to set anything up. Everything is set up within my local IDE. It's with all the integrations. I can look at the remote event object. I can then do step-through debugging, showing the IP address, which is going to be dumping that. And this is literally a tick box on the right-hand side and sets up a remote debugging session to something in the cloud, tears it down afterwards, allows you to be able to test connectivity properly in the cloud without having to jump from your IDE. So yeah, lots of functionality being built by us and other people to make this simpler. Another big thing I hear about is lock-in. And lock-in is, of course, something you need to think about. But what actually is lock-in? Lock-in is not about being sort of trapped into something, but lock-in is actually about switching costs. Because every technological choice has a switching cost. And you are locked into a lot of things. You are doing something, people who are studying at Vanderbilt University, you're locked into Vanderbilt University. Sure, you could pick up and you can move and go to another course somewhere else, but that is a switching cost. You may have to move, you may have to change your course, all these kind of things, whether you've got a car or whether you've got any IT infrastructure. Even, you want to move between Python and Node, that's a switching cost, that you're locked into Python as much as it's going to take you time to migrate your application to Node or TypeScript or whatever, or from one database to another. So the real question isn't, will there be any cost to switch between different architectures, but are those costs reasonable and manageable? And I will argue that actually serverless reduces the traditional lock-in, because with serverless, you're not locked into any long-term contracts or pre-provisioned infrastructure. You can, shut down your environment, walk away, move anywhere you're going, and because you've only got pay-as-you-go pricing. The integration is standard. It's often RESTful APIs. There are, well-documented SDKs, standard interfaces. Switching costs are much lower than having to build your own abstraction layer. And the alternative is often worse, or what I talk about, what you avoid building. And if you had to build your own private cloud or a multi-cloud abstraction layer, introduces massive complexity and operational burden. A lot of private clouds are expensive, and it's hard to keep up to date. And abstraction layers also limit you to then the lowest common denominator of features. It kills that innovation, that flywheel I spoke about earlier, makes it much slower when you need to provision kind of things. And then, if you're also building with a modern architectures using microservices and containers or whatever, or Lambda functions, ultimately, what is it? It's your code. It's your Java code. It's your Node code. It's your Python code. It's really easy to be able to pick that code up and move it anywhere else, even externally out of AWS. And ultimately, you just need to often change your adapters, or if you use a managed service, for a streaming protocol, for example, it's often just a small JSON schema that's slightly different to be able to move to various kind of things. So if you are building modern architectures, this enables agility. If you use tools like Docker containers and standard APIs and infrastructure as code tools, if you're using Terraform or AWS ones, this all improves portability. So many kind of things. If you're using databases, for example, whether you use a managed database offering, it's Postgres, it's MySQL, it's all these kind of things that you know and love. You can, pick up your data and move them anywhere else. But the whole big point about the lock-in is this: you're locked in for great reasons, because you really want to take advantage of what the capacity is provided, the scaling, the security, and all this kind of things. And so I would very much avoid not just doing something because of lock-in, but you can think very clearly about your switching costs. And if you're using open source libraries and you're using open source things, it allows you to do that. From a lock-in perspective, there are lots of open source integrations that you can do with lots of serverless services, whether you're using OTel for observability, or you're using, connecting to Kafka, or provisioning Kubernetes. And Kubernetes is a super interesting one because there's sort of two parts to Kubernetes. One is running containers at scale, where you are using it as an orchestrator. And that is great, but if you run your own Kubernetes infrastructure, that is a huge amount of super hard work. I would sort of encourage everyone to think about some of those decisions if you're just using Kubernetes just to be portable, because Kubernetes is portable, but running Kubernetes across on-prem and various infrastructure providers is a huge amount of heavy lifting. So that's one part of Kubernetes. The other part of Kubernetes is the Kubernetes API. That's fantastic. This is, a standard API that you can use to deploy applications, to scale applications, to do all of that. And a lot of serverless services use either use a lot of Kubernetes constructs to be able to use the Kubernetes API to then deploy databases or deploy stateful stuff, things that are not running on Kubernetes, but elsewhere from Kubernetes behind the scenes. There are lots of open source frameworks, serverless framework. I mentioned Terraform. We've got AWS ones as well. OCI is the container image format. That's entirely open source. You can, use that as well. Power Tools, I mentioned before, is an SDK for building serverless application. That's all open source. What Lambda runs on, Firecracker, is an entirely open source virtualization layer. People are using it in amazing places, fully open source. And then just in terms of visibility and things, the Lambda roadmap is open source. It's not fully open source. There's some cool things being worked on, but if you go to GitHub and you look up Lambda roadmap, a lot of the things we're working on in the future are all over there, and we love getting your questions and comments as well. So that just talking about a lot of the things of why you don't do serverless. But I think serverless is an investment in the future, in your future. And the cool thing is when you are building serverless applications, whether it's on AWS, I said, or elsewhere, there's always going to be more work on building well-architected fundamentals. And this means best practices as it's running in the cloud. Everybody's going to be doing more work on developer experience. Everybody's going to, have more improved controls over other services, integrations, simpler, broader, more secure, highly scalable. And this is, I think, when you're building serverless applications, you are really using a superpower to be able to get the most bang for your buck and the most bang for your time as well. And your time is often the most important thing. And you get fun because you're able to build your applications and you'll be able to explore and do a whole bunch of kind of things. So I'm finished with the most kind of thing. Happy for questions and comments. Just some other kind of things, some resources as well. AWS Builder Center, you can sign up for a Builder ID, and this gives you a whole bunch of information. And there's actually skillbuilder.aws, which is hundreds of hours of free courses as well, which is super useful. And so once you set up your Builder Center profile, lots of access to lots of information and content as well. From a serverless perspective, we've got serverlessland.com. That is sort of your best place for all things serverless on AWS. We've got patterns you can download, which is just clone a repo, able to deploy a whole bunch of serverless applications. It's got learning guides, workshops, live streams, videos, everything over there. So yeah, so that's a lot of talking from me, and I appreciate you spending the time. I'm virtually with you in Nashville and wherever else you are in the US and across the world. But yeah, thanks so much for spending the time. I wish you well in your serverless journey, and I'm looking forward to all the cool things and the talks later today and all the cool things that you're going to be building in the future. Thank you.
Thank you, Julian. So maybe I will start with one very simple question. You mentioned at the end that time is the most important thing. That applies to experienced developers, but also to people that are just starting, or maybe they are not yet developers, like they may not know what are containers and things like that. So
Yeah.
serverless can really help. But I wonder, what are your thoughts about, future? Like, can we make it much easier for people to build, whatever they want to build without getting to know all those services and APIs and tools and open source projects and all of it? I mean, for people that are inside, it's like fish inside water.
Yeah.
It all makes sense. But from the people from outside, it's like, oh gosh, I will be
Yeah.
like, drowning in all that knowledge I need to know for when I want to build simple to do application.
Yeah, definitely. There are two parts of it. I've sort of deliberately gone through, a whole bunch of serverless things to show the breadth of serverless because it isn't just code, it is databases and all those kind of things. And so, yes, initially that can look completely overwhelming. But that being overwhelmed is more about you've got a lot of choice. And generally, what are people going to do? They're going to maybe write a little bit of code and connect to a database and put an API. That's it. And so the industry wants to make that as simple as possible. And I think with serverless also being 10 years old, Gen AI models are actually being incredible in the way they can understand how to build applications. So I did that demo of the MCP server, and this is a great unlock, whether it's AWS or other kind of things, where entirely in natural language, I could build that to-do list application. I didn't need to know anything about servers. I didn't need to know anything about serverless. I was just able to use natural language to build that as well. But the cool thing is it means it's not just a toy. That to-do list application, it may sound like a simple app, which it is. But if I was to get, 1 million requests to that application on day one and scale up crazily, I'd actually have to do no architectural changes. That would just work. I may need to look at some throttles and limits, but that would be it. And so I think using Gen AI to build applications with MCP servers using natural language, I think is probably the most incredible unlock we've seen in IT computing as well, where you've got all these services on the cloud or anywhere, even locally, that you can just use. Type in some natural language and off you can go and explore. And you can grab source products. And the cool thing is you can GitHub, you can clone anything, open it up in your IDE and say, explain this to me. I don't understand this. Please explain this to me. And that is a superpower for me as well for learning.
So let's check if we have questions from audience, like both in the room and from remote. If you are remote, please raise your hand. And if you are in the room, also maybe raise your hand or ask a question. So do we have questions?
I can volunteer, Alec.
Hey, Pedro.
Go ahead, Pedro.
Yeah. So no, thanks, Julian. Nice talk. You mentioned a lot of technologies. My question was for example, with serverless, really Amazon set the standard. So when you create Amazon Lambda, everybody's copying Amazon Lambda. So now you have Azure functions and Google functions, and so it's you set the standard. I mean, S3 is the standard. So everybody has to use the S3 APIs. So I was wondering, because now, for example, in AI, people are using this N8, 9 tool for doing pipelines, but what will be the standard for serverless agents? Because, for example, you have a lot of projects, and I am a developer, and what I'm going to use. If I'm using serverless, I know that I have Lambda, and I know that there are many services like Lambda, so they are like clones. You mentioned this agent core in Bedrock or something like that. What will be if I would like to develop a serverless agents? Because you said, okay, functions are short or Fargate is long, so use this. So do you think that will be the standard and all of the other clouds will copy you here, or what is the direction for serverless agents here?
Yeah, definitely. That is a great point. I think we, from an AWS perspective, we're actually not trying to create the new kind of standards for this, because the industry is already figuring this out and coming up with some cool things. So, for example, MCP is a standard that came out of Anthropic, but that is now globally recognized and a standard. And that is fully supported in Agent Core, for example. A2A is a Google initiated protocol, and this is when agents are going to talk to other agents, so slightly different from MCP. But again, we're building this functionality into Agent Core as an example, and so those are standards that are coming up, that are already in there. Another good example is OpenAI's standard for talking to LLMs. Is becoming an open standard, and even though it's OpenAI, because whether you're using Anthropic or using OpenAI or a whole bunch of different LLMs, a slight little difference in that JSON payload you need to send, and so we actually trying to adopt industry standards that are coming out as well for that. So I know your question is, well, is AWS leading the charge in this as well? We're trying to be as open as possible because I don't think we've quite figured out what the new protocols are, but we're willing to support everything that is. And we've got another open source tool we've got is Strands, and that's an agent SDK for building agents. But you can use LangChain, you can use Crew AI, and all these kind of things. So yeah, I hope that first of all, I don't think there's always going to be a protocol that rules them all. But I think the cool thing about all of these building with serverless is that there are plenty of options, and we'll hopefully support them all. And I think the industry having lots of eyes on these protocols and developing them in the open is amazing, because it shouldn't have to necessarily come from one person or one group.
So there is not really serverless agents like servicing Amazon now.
Well, the agents run on whatever it is. So yeah, ultimately it's a compute substrate somewhere. But it's going to use an open source framework, whether it's ours or anybody else's. That's absolutely fine. But we just want to be able to run these things at ridiculous scale, and that's the kind of thing. And in fact, we want to have to remove the choice of the things that you need to think of and just make it simpler for you as well.
Okay.
Yeah, but it is going to be interesting if we look in 5 years' time what new protocols have come out. But I know from AWS's perspective, we're very much looking at the open source ones rather than, because we created the S3 API, which a lot of people followed. We created the Lambda, which a lot of people followed. And although it's not API compatible with other kind of things, it's similar. But I think the open source world has also moved far on that. I think we'd prefer to build things using open source technologies from the beginning, like OTel, for example. So Bedrock Agent Core Observability is all OTel based, without having to do anything that's different or proprietary.
Okay.
I see raised hand in the room.
Yeah.
Do you have a question? Go ahead.
Question?
Yes, please.
So, loudly or?
Yes.
We can hear you.
Yes, okay. So thank you, Julian, for the great talk. Here is Anderson Andre from Yale Press. My question is about one of, at least the way I understand, one of the key, the first requirements for deciding to go serverless, let's say, which is the execution time of the function, the duration of the function. So for me, when I see the definitions of serverless, one of the first things is that it said it should be used for fast executed functions, for fast functions. And so here talking about milliseconds to seconds, for example. But when we go towards AI and Gen AI with serverless, I think we go out of this range of execution time, right? So what do you think about it? And yeah, what are your thoughts about it?
Certainly. So that was when I was talking about the difference between the agents and the tools. Because often tools is just an API call, and that Lambda functions can run for up to 15 minutes. You can use serverless containers, which is with other services, and they can run forever. So you do have a serverless option whether you want short running or long running. But my point with agent core runtime was you shouldn't even need to think of that or make that decision. Why not just run your agent in somewhere that the time to run you don't even need to make that decision, because I hear you that every time you think about something, how long can it run for? And so, yeah, Lambda functions can run for up to 15 minutes, or you can use a container that can run for longer. If you're particularly running AI agents, you can use the managed service that is the sort of best of both worlds, and you don't really need to think about how long those agents are going to run. But there's a second follow on to that is the people who are building the most sort of successful applications are also decomposing them into their component parts. And so they will be able to use smaller duration things which can scale independently, have different cost independent profiles, can maybe use different models, can use different kind of things. And so shorter running things is actually a superpower. But yes, you don't want to be caught in a sort of one-way door where you can go through and the door slams behind you and you're caught between that as well. So yeah, using managed services avoids the long running function issue. But a lot of the tools that are going to run, whether that behind APIs, generally those are going to run well below 15 minutes probably a couple of seconds to do a database API call if it's going to be a read and write.
Okay, so in that sense, you think that it doesn't disqualify, let's say, the title of a serverless application if it's running for longer?
No, and you'll probably have some serverless purists who will call me a heretic for saying that, but serverless is not about the time. Serverless is about reducing the infrastructure you need to manage, and whether it's going to be short running or long running, that's not going to be a blocker. I mean, when you think about a serverless database, for example, you don't think about transaction time or any kind of that. That's not a concern. So yes, serverless started with Lambda with being a particular compute time, but as things evolved, things are far more flexible nowadays.
Okay, thank you very much.
Any other questions? Okay, I think we don't have. Oh, you had questions? No. Okay, we don't have any more questions here.
Okay, so if we do not have any more questions, you can always ask the question in Discord channel if there is anything you want to ask afterwards. Otherwise, we will and you can continue asking questions as we go. We have the interactive part that we would like to do. It should not take long, and after that, if you have any questions, we can finish that session with questions. So let's maybe switch to that part, unless somebody has the raised hand and want to ask something.
Well, just to say, I'm also available. You can contact me, LinkedIn, Twitter, whatever, via email. Happy to answer questions or help you out as well if it's external to what you're doing today.
Thank you, Julian. That's great. Okay, I will switch now.
So
If we still have time,
Yeah.
maybe can I do another question?
Yeah.
Yes,
sure.
go ahead.
Stand here so they can see you.
Yeah.
It'll be better if they can see you. Just stand in front of the screen.
Okay.
Yeah.
In another direction, Julian, about the energy consumption around these tools and these services and components that you exemplified. For example, I imagine that if we use Gen AI to generate the serverless services, we are going to expend much more energy to use the models and to produce it. So do you have any thoughts about that, or have you seen any numbers?
Yeah, certainly. I don't have hard and fast numbers, but two things to cover. If your AI tool is going to be much quicker at building a serverless application because it's able to use an LLM model, hopefully that should be able to use less energy. Because if you're spending 2 weeks on your laptop or a server or that kind of thing, running that 8 hours a day to do a whole bunch of coding, when it is maybe 10, 20, 30 LLM calls, potentially that can be quicker. So there is that consideration of time equals compute power equals money. So if you can do that more efficiently, but the big elephant in the room is, I think the industry is still figuring out what the heck this energy requirement and the cost requirements of Gen AI workloads are. And I'm the first one not to shy away from that, because we don't know. The world's building these giga Gen AI clusters. There is a big energy requirement for that, and whether that is going to be cost prohibitive in the long run, or whether companies even building with Gen AI or on Gen AI are actually going to be able to make their margins after they've paid their power bill and their GPU bill is unknown. So that's on the creation side. On the other kind of side, we are finding, at least with AWS, that at least if we're able to run as a shared data centers, our energy efficiency, I would say, much more efficient than you'd be able to do it in your own private data center. So, for example, we've got huge amounts of innovation in the way we actually do our cooling, in the way we actually build our servers and do all this kind of thing. And that's not just AWS, it's many cloud providers. There's a real big focus on making things as energy efficient as possible. And the cool thing is because you're also sharing that infrastructure with everybody else, if you had to spin up something or an HPC cluster or something to do your own kind of workload, that's going to be super expensive and energy efficient. But when you can share those resources, that you can use it with a lot of other companies, that is super useful. And just a technological example that recently, so I spoke about Bedrock is our inference LLM, and we run all the different kind of models. Previously, we used to run different compute clusters for each model, and so that was simpler in a way that we knew that that capacity was for DeepSeek, and that capacity was for Nova, and that capacity was for Anthropic, for example. But we've actually, changed that model and be able to have a much more fluid compute abstraction for that, where we're able to be able to have multiple models hosted within a single compute cluster and be able to, load models into a GPU. It does take a few seconds or minutes and spin them down, but do that in a far more elastic way. Because the worst thing from a cost perspective from us and from an energy burning perspective is having workloads, computers sitting there doing nothing, just waiting for workloads to happen. So in a way, the bigger the pool of the infrastructure with way more efficient computers behind the scenes and way more efficient cooling and way more efficient energy production, I hope that we be able to get to a way to at least do this as energy efficient as possible. But yes, it remains to be seen whether our whole AI build out over the world is going to, the value for the money for what people are paying and also for environmental impact, whether that's to be seen.
Okay. And do you have any services in that huge list of services from AWS to measure the energy consumption on serverless applications or services?
It's a difficult thing to answer because we don't have exact tools, although you can work out proxies for some of your kind of things. And the part of the problem is because it's running on a whole pooled shared infrastructure, is you don't necessarily know your impact on that pool. So, if you were one customer, if there were 1,000 servers behind the scenes and it was the middle of the night and you were running your inference job and there was no one else running it, that would be super expensive for you. But during the day, when there are a million other customers using the same infrastructure, it would be far cheaper in aggregate. And so it's tough from our side because we would love to provide all the absolute in-depth usage things, but it fluctuates so much that it's actually quite a hard problem to solve, because by aggregating it across lots of customers across lots of geographic areas, it's the most efficient way we can do it. But to then attribute what your individual cost does, your individual cost usage of that whole big infrastructure is tough. I don't want that to come across as a Weasley answer, but it's a tough thing, and lots of clever people internally are trying to figure out the best ways we can help people with that.
Yeah, I agree. Okay, thank you very much.
Pleasure.
Any more questions?
No, I think it's no more questions here. Thank you.
Okay, we will go to that online polls, the interactive part, and you can still ask the questions at the end of our session. I will share the screen starting with our historical polls, so you get some idea about what were the answers to the questions, and then we will have the audience participation. So let me share my screen. Okay. I think you should see my screen now. And this is, you can see that, we started doing those interactive questions in 2022. And you can see and all those slides and what you are seeing now are linked from the main program website of the workshop. So, anything you see, you can go there and look in more details. I will be just talking very high level. And Pedro, go ahead if you want to add anything to it.
Well, yes, normally it's a classical thing we do in this workshop, that we ask two questions to the audience during the past years. A first question is about the main challenges in serverless computing, and the second one is about the future of serverless computing. The first one about challenges, we see that people coincide normally that handling a state is one of the most important things. And you also see always like cost, billing, and then productivity, consistency, latency, transparency. But state is always there. And I mean, we are really interested in what the community is saying, but I think even after many years, many are repeated. like startup latency and cold starts continue to be there, and developer complexity and debugging, and so many things are still there. Like here, main challenges, we also start to see things like AI and really serverless things, it seems to be moving towards AI. So we see there GPUs, we still see locking, but we also see agents, and we see other things here. And maybe if we move now to the second question, the future of serverless computing, then people have to be more speculative. What are we going to do next? Like, and people said like moving serverless everywhere, like it's like megalomaniac, that we are going to invade the world and all technologies will be serverless. But then really many people said that the future is also AI, and AI starts to appear in the previous ones and keeps appearing now, and more AI things are appearing here. Like we see here convergence with Kubernetes, but we also see a lot of things connected to AI and other backends for serverless computing. Here we also see AI inference, its deployment, serverless GPUs. So we see this really shift towards this kind of AI concepts that are becoming the future and the present of serverless computing. And then we also did the last time a question. This WoSC was this summer. It is a virtual workshop. And we start to see here, we start to ask about serverless AI, because we also think that serverless AI, it's becoming its own topic, even maybe the future of serverless. And people here outline many interesting concepts connected to serverless, like cost and complexity, but starting up to appear other more AI connected things like GPUs, like agents, like MCP, like pipelines, another kind of concepts that are connected. So I think that we can go now for a very fast poll. We leave these questions apart, maybe Alec, and maybe I share my screen. We make the questions and we see what the audience tell us today. So then
Sounds good. Go ahead, share your screen.
I'm sharing now my screen. And then here, I will go live here with this. So you can enter menti.com and use this code and start answering the first question. And we will see here appear these your answers. First, challenges of serverless computing. Maybe we give some more minutes to see, but this is converging. So, okay, I think that we can stop here and move to the next. No, let's give a couple of minutes more to see if people contribute. Yes, sustainability, energy, state, it's always there. And cost, this is appearing all workshops. I mean, the audience always talk about the state and cost. But now sustainability, it's becoming important with energy, and AI things like agents, like GPUs are also appearing there. Okay, I think that we can now move to the next question. That is this one. What is the future of serverless?
And think about really future. It's like not just the next year, but where is it going? I like that server full again, right? Bringing more server into serverless. When you say quantum less, it may mean quantum more, but we see. It seems that AI in simplicity goes together.
Yeah, I think now it's becoming more stable. So yeah, I mean the conclusion is like you said, Alec. I mean AI, agentic AI, and simplicity are taking over, and many people say it's the new normal, super easy to use. I mean around simplicity, accessible everywhere, and yet the more crazy things here, but yeah, this seems to be like the clear future, like using AI for simplicity, using agents. Then last question, because also Alec and I we were discussing and with others about the future of this workshop because it's 10 years. If it's become a standard, we move to another topic. But maybe we were considering that even serverless AI it's becoming like a topic in itself. So if we were to call for topics in serverless AI or think what is going to be done in this topic, what can you suggest as the audience? And this is the last question. Okay, it's interesting. Now we are seeing how programming models, GPU support, but also many things connected to stateful applications, vector DBs. AI makes PL obsolete. What is PL? Programming languages?
Yes. I think it always shows small letters, not capital letters, right?
Yeah. nice. Unexplainable billing. So very, very interesting. I think we can all get ideas about this. I mean, the community we have here, academia and industry. So we have interesting ideas from all of you. We are sharing these word clouds. So we will also publish them in the Discord channel. And I think, Alec, that we can finish here with the meters and move to the sessions if you want.